right, let's jump right in. We're going to talk about something that, every single Java developer deals with, but honestly, not everyone gets it right. I'm talking about exception handling. And look, it's so much more than just some syntax you have to remember. It's really an art form that separates okay code from truly great, robust code. In this quote, it really hits the nail on the head. We've all been there, right? Just slapping a quick try-catch block around some code to make the compiler happy and get things running. I know I have. But the real question is, how do we go beyond that? How do we make our error handling truly robust, something that's actually helpful and easy to maintain? That's the leap we're going to make today, from code that just works to code that's actually great.
And you've got to understand, the stakes here are incredibly high. This isn't just about a minor hiccup. No. If you get this wrong, you're basically planting little ticking time bombs all over your application. We're talking about bugs that are completely invisible, right up until they detonate and bring your entire system to a screeching halt. And you know it's always going to happen at the worst possible time.
Okay, so let's start at ground zero, the heart of all of this, the catch block. We're going to break down 3 simple but super powerful rules to make your catch blocks clean, clear, and most importantly, actually effective.
Rule number 1, use meaningful messages. Seriously, look at this bad example. It just prints error. I mean, come on, what does that even tell you? Nothing. It's a total dead end. Where did it happen? Why? Who knows? But now, look at the good one. It tells you exactly what happened. Cannot divide by 0. It even gives you the original message from the exception. Now that is a useful clue. It's like a big flashing arrow pointing you right to the source of the problem.
And that flows right into our second rule, catch specific exceptions. Catching the generic exception class, well, that's just lazy. It's like trying to catch a specific bug in your garden with a giant fishing net. Sure, you might get it, but you'll also catch butterflies, bees, and your neighbor's cat. It's too broad. You end up handling errors you never expected. But catching a specific arithmetic exception? That's precision. That's like using tweezers. You're saying, I know this exact problem can happen here, and here's exactly how I'm going to deal with it. It makes your code way more predictable and a whole lot safer.
All right, and this is a big one. Rule number 3, do not ignore exceptions. An empty catch block is probably one of the worst things you can do in Java. It's called swallowing an exception, and you're essentially just telling your program, hey, something broke, but you know what, let's just pretend it never happened. This creates literal ghosts in your machine. You'll have these bizarre bugs, and you'll never figure them out because there's 0 evidence that an error ever even occurred. It's a nightmare for debugging.
Okay, so we've got the catch block down. But here's the thing, good exception handling is way more than just syntax. Now we're going to pull back a bit, zoom out, and look at the bigger picture, the overall strategy.
So this leads to a pretty natural question, right? If ignoring exceptions is so terrible, should you just, wrap absolutely everything in a try-catch block? Just catch them all?
The answer is a hard no. Actually, sometimes the smartest thing you can do is nothing. You let the exception travel up the call stack. Think about it. If some low-level method deep in your code runs into a problem, does it really have enough context to fix it? Probably not. So instead of trying to handle it right there, it should just pass the problem up to whoever called it. That higher-level method has a better view of the situation and can make a smarter decision. It's like passing the buck, but in a good way. It keeps your code so much cleaner.
And this is where the full try-catch-finally structure really shines. The finally block is your ultimate safety net. You have to remember this. It doesn't matter what happens in the try or catch blocks, the code inside finally is guaranteed to run every single time. And this is absolutely essential for cleanup. Imagine you open a file or connect to a database. If you forget to close it, you create a resource leak that can bring your app down. But if you put that cleanup code in the finally block, you can sleep soundly, knowing those resources will always be closed.
Here's a pro tip for when you're getting more comfortable with this stuff. Don't be afraid to create your own custom exceptions. Yeah, a standard I-argument exception is fine, but how much clearer is something like an invalid transaction amount exception? It's so much more descriptive. It turns your error handling into a really expressive part of your application's own language.
But a quick word of caution here, don't go crazy with it. There's a balance. If you start wrapping every single line of code in its own try-catch block, you're going to end up with a nested mess that's impossible to read. Remember, the goal of good exception handling is to make your code clearer, not to bury the logic under a mountain of catch blocks.
Okay, we've talked structure, we've talked strategy. Now for the final piece of the puzzle. Let's talk about taking this from your local machine to the real world. How do we write error handling that's truly production ready?
And this is a huge one, folks. Stop using system.out.println for errors. It's fine when you're just messing around on your own computer, but in a real production environment, it's totally useless. What you need is a proper logging framework. This gives you structured logs you can actually search and filter, with timestamps, error levels, all that good stuff. Trust me, when something breaks on a server at 3 in the morning, those detailed logs are going to be your absolute best friend.
So let's circle back to the absolute biggest mistake we've talked about. Seriously, if you take away only one single thing from our chat today, let it be this: never, ever swallow an exception with an empty catch block. I promise you, it is the single fastest way to create those horrible hidden bugs that you will waste days, maybe even weeks of your life trying to find.
All right, let's put this into practice. Time for a little micro challenge. On the screen, you'll see some code that uses one of those big, generic catch blocks. Now, based on everything we just went over, how would you make this better? Go ahead and pause here for a sec. Think about how you could refactor it to be more specific, more informative, and just better.
And really, that brings us right back to where we started. At the end of the day, good exception handling isn't just about preventing crashes. That's the bare minimum. It's a proactive strategy. It's about building genuinely high-quality software. It's a core part of writing code that isn't just robust, but is also a pleasure for the next person or your future self to read and maintain.
And that's a wrap on the art of exception handling. In our next explainer, we're going to dive deep into the Java Collections Framework, all the cool and efficient ways Java lets us manage groups of data. Hope to see you there.